Hi, hello everyone. Good evening. This is your Ameer sir, Master Teacher of Physics at Vedantu. And welcome to another session of Rapid Sprint 2.0. And I hope you all are ready to make the session so awesome and so amazing, right? So, yes, hi to everyone who's over here. Hi, Tornado. Hi, Namdio. Kaushika. Hi. Good evening. Lot much of highs from Kaushika. Hi. Yes, after a long time. Where were you, Tornado? We also missed you in the classroom because you used to be there in the chat box with so much of activeness, with so much of energy. We missed that energy. So, how are you doing and how are you all doing? All my students, how are you all doing? Exam days are very fastly approaching. I hope you all are making the proper revision plans, right? Anyway, here we are doing a very good revision, isn't it? With a rapid sprint, we have covered many of the topics. A few more is left, and we are doing maximum number of questions also. So you don't have to worry. You can be chill. I hope you are doing your own revisions along with it, right? Yes, Kaushika, all fine, all good. Okay, so seems like everyone is fine, everyone is good, and everyone is ready for today's session and that amazing topic which we have for today's class. What is the topic which you're going to discuss? Hi, Anthony. Yes, it is the dual nature of radiation and matter. I'm sorry. If I give you the title name by this, so many of you will fail to understand. But if I tell that it's a part of modern physics, then everyone will understand because modern physics is a combination of three chapters: dual nature, atoms, and nuclei. We are doing it separately. So today we are planning to cover many questions from the part of dual nature. And don't worry if someone is lagging behind the theory. Along with each and every question, I'm going to explain all the related theory to it, which means we are going to completely learn this particular session and this chapter. What you have to do is just be with me. Together we can learn. Can you all be with me till the end of the session and make this lot much of energy? Is it? Are you gonna make it? Yes. Can I expect you all? Okay. Yes. Ronaldo, Kaushika, Anthony. Very good. Very good. Then it's gonna be so awesome. Now these are the chapters which we have done after the part 1. We have completed the part 1, and these are the topics from the part 2 of NCRT, and we have covered till wave optics, and the time have shifted from 6 o'clock to 8:15 p.m. every day. So you can catch me live at this point of time, and today we are going to do dual nature, atoms, nuclei, electronics, and communications will be happening according to the scheduled date and time. Okay, so I'm gonna hope everyone there, right? No, I'm here in this particular channel, so maybe you are attending SR classes. It's good anyway. Great. Okay, now what I want to tell you is, if anyone is new in the classroom, those who haven't subscribed, now itself move your cursor, click on that red subscribe button and the bell icon, because I have to tell you that this session and all the sessions what we do here is so much amazing. If you don't want to miss any of the classes, I think you don't want to miss it, because it's gonna give you a lot much of information regarding the topic whatever you're gonna learn, right? And regarding the entire 11th and 12th syllabus. So now itself make it sure that you are subscribing to the channel, right? Okay, so thank you so much. Regarding the Telegram group, which is Momentum with Vedantu, link is given in the description. And what happens here is, whatever questions we discuss in the classroom, okay, so prior to the session it will be uploaded in the group, so you can check this Telegram group and get all the questions that we discuss here. And one last thing, okay, it is regarding our crash course. So why we need the JEE crash course, though we are here with the, let's say, with this sprint series, it's simply because if you want to have some special attention and if you want to cover the entire concept of all the topics which is going to come for your JEE and NEET, okay, and if you want to solve as many questions as possible, wanted to clear all your doubts, and if you want to write an all India level mock test so that you can analyze how much you have learned and how much you have prepared for the JEE, then this is a best place you can be, which means come and join, be a part of Vedantu family and be a part of the JEE 2021 crash course. Now, this is the best time because, right, you are going to get 30% discount instead of paying 10,000 rupees. You'll be only paying 7,000 rupees because you have attended my class, and I'm going to give you the code, which is AMECC. Type in the code now and get the course just for 7,000 rupees. Isn't it amazing? Yes. Hoping that we all are going to see in the real classrooms. Let's start with the first question. Are you all ready for that? Are you all ready for the very first question? Yes? Yes, yes, yes. Where are you all? Where are you all? Yes, Tornado? Yes, here we go. Now, photons with energy 5 electron volt, the unit of energy here uses 5 electron volt, are incident on a cathode in a photoelectric cell. The maximum energy of the emitted photon is 2 electron volt. Now, let us understand the concept till this part of the question, right? We know that whatever is the energy given through the photon is used for two purposes. One is for the work function, which means the energy of the photons which gets collided with the metallic surface, some energy is used to take out the electrons from that particular metal, which we call it as the work function. And the remaining energy is used for giving what? The kinetic energy. So the energy given is used for two purposes, work function and the kinetic energy. So here it is given that the energy of the photon is 5 electron volt, phi naught is unknown, and the kinetic energy is given as 2 electron volt. From here you can simply find out the value for phi naught. How much? 5 minus 2, 3 electron volt, which means the answer for work function is 3 electron volt. Anyway, that's not our final answer. Let's continue reading. When photons of energy 6 electron volt are incident. Okay. Now, when photons of energy 6 electron volt is incident, let's find out the kinetic energy. From this equation, kinetic energy is equal to given energy minus phi naught, which is the work function. What is the given energy? That is equal to, that is 6 minus phi naught value we already have, that's 3, which is 3 electron volt. So in the second case, the kinetic energy of the emitted electron is equal to 3 electron volts, right? Okay, so Kaushika has already started giving the answers. Others can also start giving the answers. Be quick. So the kinetic energy is equal to 3 electron volt. The question is, the stopping potential is what? What is the stopping potential? You might be knowing the equation for kinetic energy is equal to, I think this part is not visible, so let's write here. The equation for kinetic energy is equal to E into stopping potential. You all have learned this equation, right? Everyone in the classroom? Yes. So here the kinetic energy is equal to 3 in electron volt, right? This is E V naught, cancelling E on either side. You will get a V naught value as what? 3 volt, which means the stopping potential is going to be 3 volt. But now you have to be very careful regarding the sign also. The stopping potential means the potential on the plate, right? Okay, so that you can stop the electrons. So this is the plate, the electrons are coming. What is the sign of electron charges? It's negative. So this negatively charged electrons can only be stopped by giving a negative potential, because negative and negative will start repelling. So this repulsive force is actually stopping this moving electrons or converting this kinetic energy to 0. So the potential should be not plus 3, it should be minus 3. Understood? Right? It should be minus, then only it can oppose the flow of the electron towards it. Is it clear? Everyone, Kaushika, then where are the others? Tornado, where are you all? I can't see the Josh, I can't see the energy. The class seems to be very dull. I want everyone here in the classroom to be there in the chat box, making it so great and so much, with so much of activeness. Where is it? Yes? Okay, good. So, no doubts are there, I suppose, right, Tornado? Kaushika? So yes, moving on, yes, it's a bump, fist bumping, right? Yes, good, that's great, that's great. So moving on, next question, right? Okay. So the velocity of the most energetic electrons emitted from a metallic surface is doubled when the frequency of the incident radiation is doubled. What is the work function of this metal? Let's do this, right? So let's start with the basic equation. Now, you know that the kinetic energy of the emitted electron is found out. We already have written the formula with the previous question, right? What's the formula? The energy of the photon minus the work function, right? The question is to find out the work function, right? Okay. Now, what is it? The velocity of is double. So, kinetic energy can be written as half mv square. And energy of a photon, if frequency is nu, is h nu. So, h nu minus phi naught. So, half mv square is equal to h nu minus phi naught. Good. Is it clear till this part? Now, what information is given? It is given that when the velocity is doubled, right, the frequency of the incident radiation is doubled. Now, which means if you are providing an energy corresponding to a frequency of 2 nu, what will be the energy if frequency is twice? So, it will be 2 times h nu minus phi naught will be equal to the kinetic energy, that is half m. If the frequency is 2 nu, what is the velocity? That is 2v, it is given the whole square, right? Simple. Now, making the equations 2 square is 4 times half m v square is equal to 2 times h nu minus phi naught. Yes, you wanted an equation for phi naught, so I'm going to avoid this half m v square part, right? How? Because half m v square from the equation 1, you know that half m v square is h nu minus phi naught, right? Can you all get that? Yes. So 4 times half m v square I'm going to write as h nu minus phi naught is equal to 2 h nu minus phi naught. Okay. Now, here what do you have? 4 h nu minus 2 h nu, right? That is 2 h nu. This is equal to minus 4 nu naught if phi naught, minus 4 phi naught. If you take to the right, it is plus 4 phi naught minus phi naught. It is 3 times phi naught. So, the value for phi naught is equal to 2 by 3 h nu, which is option 2. Yes. Here, another simple question, or we made this question so simple by understanding the concept. We can say in that manner also, right? Got it, got it, got it. Yes, yes, yes. I want every one of you to give me the answer before me. I know that you are super good in calculation, super good in doing the problems, right? So yes, give me the answer even before me. You all can do that. I'm super confident about it. Okay, very good. So, where is our next question? Yes, here comes the next question. What is it? When a certain metallic surface is illuminated with a monochromatic light of wavelength lambda, the stopping potential for photoelectric current is 3V0. When the same surface is illuminated with a light of wavelength 2 lambda, the stopping potential is V0. The threshold wavelength for this surface for the photoelectric effect is. Okay, so that's the equation. So again, we have to start with the basic equation, right? The kinetic energy is equal to, right, h nu, which is the energy, minus phi naught, the basic equation, right? Very good, Kaushik. I didn't see that. Very good. Keep it up. Okay. So kinetic energy is equal to h nu minus phi naught. Nobody is having any doubts, I suppose, right? Okay. And nu can be written as c by lambda, right? Okay. Now, what all are the information given? And one more, nu is equal to c by lambda. One more information, kinetic energy is equal to E into stopping potential. Great. Now, when the stopping potential is 3V0, when the stopping potential is 3V0, the kinetic energy will be equal to 3 times EV0. Right? Stopping potential is 3V0. So 3V0 into E. So 3EV0. Right? Okay. That is equal to h c by lambda. Nu is equal to c by lambda. H c divided by lambda minus phi naught. The photoelectric effect, right? The stopping potential is 3V0 when the wavelength is lambda. Okay, good. Now the question, another information is when the stopping potential is V0, what will be the kinetic energy? EV0. Okay. The stopping potential is V0 when the incident is having a wavelength of 2 lambda minus phi naught, right? What is the threshold wavelength? Threshold wavelength means when the frequency is a threshold frequency, what is the wavelength at that point? So that is contained in the information of phi naught, right? Because phi naught is given with the value of h nu naught, or threshold frequency hc by lambda. So this lambda naught has to be found out, which is the threshold wavelength. So how this can be done is by substituting for EV naught. You know that EV naught is equal to hc by 2 lambda minus phi naught. So I'm going to substitute it here. So 3 times EV naught is equal to hc divided by 2 lambda minus phi naught. Phi naught I'm going to write it as hc by lambda naught, right? So 3 EV naught is equal to hc by lambda minus phi naught is equal to hc divided by lambda naught. hc is common everywhere. Can't we cancel it? Right? Can't we cancel all the hc's? Yes. We're gonna cancel. Chop. All the hc's are gone. Okay. And okay, all my theory students are here. Prasanna, I don't think within 1 or 2 weeks this is not gonna happen. I have already told you. So let's see if there is anything. Okay, please do subscribe to the channel. Please be active here. Okay, I'm gonna remind you if any classes are gonna happen. Fine. Okay, now HC's are being cancelled. So let's do the remaining things. 3 by 2 lambda minus 3 by lambda naught is equal to 1 by lambda minus 1 by lambda naught. Right? Can you all do the theory, or if you want we can do it itself, right? So 3 by lambda naught, if you take it to the right, that is a plus, minus 1, that is 2 divided by lambda naught. 3 by 2 lambda minus 1 lambda, that's equal to 1 by 2 lambda. So lambda naught is equal to 4 lambda, isn't it? Lambda naught is equal to 4 lambda. Doing the cross multiplication, yes, simple, option A. What about others? Yes, Kaushika, very good. You already gave me the answer so much before. Great. What about others? Yes, Tornado. Great. Vijay. Okay. Yes, we're gonna. I'm telling you, like, no plans have been made till for the theory classes. If it happens, we're gonna start soon, and I'm gonna remind you. Okay. Be with me. Be here in the classroom. I'm gonna update you if a class is gonna happen. Yes. Okay. So, shall we proceed? Any doubts? No. So we're gonna move. No doubts are there with anyone. So here we go to the next. What is it? The energy of a photon. Listen, the energy of a photon is equal to the kinetic energy of a proton. Okay. What is it? The energy of a photon. The energy of the photon is given with the letter E. So the energy of the photon E is equal to the kinetic energy of a proton. So kinetic energy of a proton, that is equal to, let's say, K. So E is equal to K. That is given. Lambda 1 is the de Broglie wavelength of the proton, and lambda 2 be the wavelength of the photon, lambda 1 by lambda 2. Okay. Lambda 1 by lambda 2 has to be found out. Lambda 1 is a de Broglie wavelength of the proton. What is the formula? H divided by momentum divided by lambda 2, right? Now E is the energy of the photon. How will you write? E is equal to h nu, that is hc by lambda. Okay, lambda of the photon. What is the wavelength of the photon given? 2. So E is equal to hc divided by lambda 2. I'm going to substitute it here. Hc by lambda 2, it goes up. So writing it here. Okay, sorry. 1 minute. We made a small mistake. E is equal to hc by lambda 2. We are substituting for lambda 2, right? So lambda 2 is equal to hc by E. So it is not lambda 2 here, it's E here. Okay, that's all. Okay. Now what is left? H is cancelled. 1 by C. E is there on the top. C is at the bottom at the denominator. P. How will you write the momentum? Of this proton? Momentum is equal to root of 2m into kinetic energy. Right? Can't we write this? Momentum is equal to root of 2m into kinetic energy. Yes, we can. So this E by Cp is equal to E divided by C into momentum is root of 2m into kinetic energy. This kinetic energy is given as E according to our first statement. So substituting that as E. So E divided by root E. What is E divided by root E? That is E raised to half or root E. So lambda 1 by lambda 2 is proportional to E raised to half. Right? Oh my god, so chats are being flooded. What happens? What is no reply for what? Okay, so theory we are gonna start soon. Okay, fine. Theory means the theory of. I hope you know what a theory is. Right? Is everything fine? Okay, I'm not able to understand what the language is. Like I think you are talking Tamil, right? Okay, so please maintain the decorum of the class. That will be best. That will be better, right? I know a bit. கொஞ்சம் கொஞ்சம் தான் தெரியும் எனக்கு ரொம்ப எல்லாம் தெரியாது that's the max I know in Tamil, so not more than that. So Sabu and everyone, shall we continue from where we have stopped? No doubts till now, I suppose, right? Okay, so here we go. Next question. If K1 and K2 are maximum kinetic energy of photoelectrons emitted when the light having wavelengths lambda 1 and lambda 2 respectively incident on a metallic surfaces, if lambda 1 is equal to 3 times lambda 2, how are you going to compare this K1 and K2 values? Okay, that's a simple question. So the answer can be found out by how can we find the answer? How can we do that? Yes, we can make use of the simple equation of kinetic energy is equal to energy of the photon minus phi naught. I hope you all know this formula. Most of the questions are being done from this particular chapter with this formula, right? Okay, so shall we continue with this? So the kinetic energy is K1. What's the formula for energy? E is equal to h nu or hc by lambda, because the frequency is equal to c by lambda. So the energy is K1 when the wavelength is lambda 1. So energy is equal to hc by lambda 1 minus phi naught. And the kinetic energy is K2 when the wavelength is lambda 2. Right? So whatever it is given in the questions, we have applied it over here. Okay. So you are also a Tamilan. Very good, Kaushika. So you will all have to teach me Tamil. Okay. So is this part clear till this now? Okay, now we're going to apply 3 times lambda 2 is equal to lambda 1. So I'm going to substitute for lambda 1 as K1 is equal to hc divided by lambda 1 is equal to 3 times lambda 2, right? Lambda 1 is equal to 3 times lambda 2 given minus phi naught. Now what is asked? The question is to compare K1 and K2 by 3. So what I'm going to do is I'm going to find out K2 by 3. So K2 by 3 is equal to dividing the entire equation by 3, that is hc by 3 times lambda 2 minus phi naught by 3. Now comparing this K2 by 3 and K1, that's what is there in the options, right? Okay. Now if you compare, K1 is hc by 3 lambda 2, K2 by 3 is also hc by 3 lambda 2. Now here you have phi naught by 3, here you have phi naught. So the value that is being subtracted is greater here. So if a larger value is subtracted, K1 will be lesser. Here a smaller value is subtracted, so K2 by 3 will be greater. So which option? K1 will be lesser than K2 by 3. We have the option A. Very good, Kaushika. Yes, we'll start with G. Don't worry about the theory. Now be there with me. I think I'm explaining enough theory when we are moving on with the question. So just be with me. You are slowly going to learn the theory with me. Okay. So where are the answer from other people? I'm not able to see anyone's answer. Where you are? You are sleeping or what? Let the class be energetic way. I want everyone or try your level best to give me the answer even before me giving you the answers. Okay. All good. Fine. I'm cute. Thank you so much. Means a lot. So this can make my day, I suppose, for the day at least. Okay, so Sabu, let's concentrate here. No personal messages. You can ask me any doubts. We'll clear it out. Okay, so here we go. Moving on. Okay. What is this question about? Listen. Yes. A monochromatic light of frequency 6 into 10 power of 14 hertz is produced by a laser. So if the frequency is that, let's find out the energy of the light or a single photon. Energy of a photon is given as h nu. What is it? 6.6 into 10 power minus 34 into what is the frequency? 6 into 10 power 14. So this is 6.6 into 6 into 10 power minus 20, right? So let's use some light colors, right? Okay, so we got the energy of a single photon. The power emitted is, power means the energy per second. The amount of energy emitted from the laser per second is 2 into 10 power 3, right? How many photons per second by the source? So if you want to have an